In this video, we're going to take a look at the concept of electrolytes versus non-electrolytes, and that's using solubility rules to assign whether something is an electrolyte or not. And what I want you to understand is that electrolytes dissolve to form ions. A good example is sodium chloride. And you know that if you take solid sodium chloride and dissolve it in water, you get Na plus and Cl minus ions. And so if I were to have a beaker, I would have little sodium plus ions and big Cl minus ions. And there would be an equal number of them because every time I dissolve one sodium chloride, I get one of each. And the term electrolyte just means that it conducts electricity. Why does it conduct electricity? Because it makes ions. On the other hand, we have non-electrolytes. They do not form ions when dissolved. And there's two different reasons for this. One of them is that they're covalent compounds, right? And they can't make ions. That's not the type I'm concerned with here, but an example might be something like glucose or sucrose. Those are things that are completely covalent and just can't make ions in water. And so, by the way, they don't conduct electricity. Other things that don't form ions when dissolved, they don't form many ions because they're insoluble. And we'll get to what makes something insoluble in a little bit, but a good example might be magnesium carbonate. When I put magnesium carbonate in a beaker of water, I have my liquid, and then I just have magnesium carbonate powder on the bottom. There's a tiny, tiny, tiny bit of Mg2 plus and CO3 2 minus, but the amount is basically zero. And so that means that I would call it a non-electrolyte. And I would assign it a phase label of solid in a chemical equation. On the other hand, sodium chloride, when I use the phase label NaCl aqueous, what I really mean is that it's making Na plus and Cl minus. The next step you might be wondering about is, okay, so I have an electrolyte, and electrolytes make ions, so I give them the aqueous phase label. Non-electrolytes don't make enough ions to care, so I give them a solid phase label. Okay, how do I make that decision? So I want to present to you this solubility chart. And I want to point out that these are general rules. You notice that there's a rule on the left, and then there's exceptions on the right. So all of these rules have exceptions. And what I want to point out, this chart is something that you can work through. You work your way from the top down. You look at a rule and you say, oh, well, sodium chloride. All right, NaCl. Hey, look, there's a group 1A. It's totally soluble because where I am in the rules, no exceptions. I'll give it an AQ phase label. Or maybe PbCO3. So if I look at lead 2 carbonate, and I'll erase what I've done here so that it's a little easier to see. With lead 2 carbonate, I work my way down. All right, it's not a group 1A, so that rule doesn't apply. It doesn't have nitrate, acetate, or chlorate, so it doesn't apply. It doesn't have a halide, right? This anion is not from group 7. It doesn't have a sulfate. It doesn't have a hydroxide. Hey, I made it all the way down. What's the rule? Most carbonates are insoluble, and I check over on the exceptions, and I notice that lead is not group 1A and not ammonium, so I give this a solid phase label. It's clunky, but it'll get you where you need to go. I want to look at some trends, though, that show up in this table for just a second. I see a trend that a lower charge is more likely to be soluble, aqueous, right? The things that are up in these upper sections are mostly 1 plus or 1 minus, and the exceptions mostly have higher charges attached to them. On the other hand, higher charge is more likely solid. Yeah, hydroxide is a -1, but look at the rest of these. They're all 2 minus or 3 minus. And so if you want to use sort of a rule of thumb in your head, look to the charge. Big charges are probably solid. Little charges are probably aqueous. However, there's an easier way, and that's what I want to introduce to you next. What you see above is our kind of clunky solubility chart. What you see below is a grid version of basically the same thing. And what I want to point out is that when two ions meet, if you see a gray box, that's insoluble. That's the solid phase label. So something here would be solid, or something here where that's not gray would be aqueous. So for example, if I do my same thing with sodium chloride, I look at the intersection between chloride and sodium, and I see that it's white, so I say aqueous. Or like our previous one, lead 2 carbonate, I find the intersection of lead 2 and carbonate, and I notice that where they meet is a solid. So I use that assignment and I use that chart. This is a chart that I'm going to give you on quizzes and exams. It's much easier, and you still see the same trend. Look, the gray boxes start to show up at the intersection of higher charges, right? These things over here are mostly higher charges. Again, soluble things get an AQ phase label, insoluble things get a S phase label. That's going to be important for future skills. So let's take a little time to practice. Here are a number of compounds, and I want you to classify them in a couple of different ways. I would like to cross out this acid or base. That's not a classification that I want to make. I want to do as a strong electrolyte or weak electrolyte, and then do solid or AQ. Remember, strong electrolyte is AQ, and weak electrolyte is S. Take a moment. Use either the solubility table or the intersection chart, whichever one feels more comfortable and natural to you, and assign these phase labels. Pause the video, check back, see how you do. I hope that you found that HCl, H isn't on the list, but Cl sure is, and this is definitely a group 1, that this is an aqueous phase label. Similarly, sodium nitrate is aqueous, since I've got a group 1 and a nitrate. Lead 2 chromate is a solid, if you look at where that intersects. Silver carbonate is a solid. Potassium hydroxide is aqueous. And then look at this one, C2H6. One of these things is not like the other. This is not ionic. So in other words, don't get fooled. Make sure a compound is ionic before you get suckered in and try to find it on a list and try to assign it. By the way, these aqueous, like we said before, anything that's aqueous is a strong electrolyte. Anything that's aqueous is a strong electrolyte. Anything that's solid is a weak electrolyte. Now that you know something about solubility rules and this skill of deciding solid and aqueous phase labels, you're going to have to put that to use in some future bits of chemical equations. So make sure that you file this skill for later use.